Good morning to all. I talk about that hybridization for ionic species like cation or anionic species. Cation or anionic species. For example, in first like that cations. Any simple example for the cations? I 3 plus. I 3 plus. For example, I 3 plus mean 1 I 2 iodine sub. For example, is a central atom is a surrounded atom and the valency of iodine is 7. For example, 7 electrons for the iodine valency electron to put on the valency and 7 plus if any positive charges to neglect the one valency if you negative charges to addition of one electron, so this electron will be neglected due to the high plus charge of the central atom. So 7 minus 1 6 electrons will be present in the total iodine, and 2 surrounded iodine will be bonded with 2 electrons. For example, 2 sigma bonds will be present and totally 4, that means 2 lone pair electrons. So I3 minus plus contains 2 sigma bond, 2 lone pair electron, and totally for that 4. The 4 mean sp3 hybridization with 2 lone pair electron. The most of the compound become to bent or angular form. For example, I plus the lone pair, then that is a form. One second. Any another one cation. For example, NH4 plus is the nitrogen is a central atom and 4 hydrogen became a surrounded atom. So the valency of nitrogen is 5, but nitrogen having for the charge for plus, so 5 minus 1 in 4 electrons present in the nitrogen. Total valency becomes to 5. The charge of cation becomes to minus 1. So positive charge to less than 1 electron. The 4 electrons will be remaining present in the nitrogen valency cell. In totally 4 hydrogen to the surrounded atom, H. So totally 4 sigma bonds. So NH4 and 4 sigma bonds. So complete sp3. So sp3 mean in absence of lone pair electron, so perfect tetrahedral. For example, N, H, and H. That's all. Any other for the negative ion? Like I3 minus. The I3 plus is an angular form, but I3 minus same. 1 iodine became a central atom and 2 iodine became a surrounded atom. For example, valency of iodine equal to 7. The charge becomes the central atom became negative charge plus 1 electron will be added. If any negative charge present, 1 electron will be added. In totally 8 electrons present in the valency of the iodine, valency shell of the iodine. For example, surrounded atom becomes a 2 iodine. So these are all lone pair. So 3 lone pair and 2 sigma bond. Totally I3 minus contains 2 sigma plus 3 lone pair, and total values are 5. So sp3d with 3 lone pair. The 3 lone pair becomes to that the molecule becomes to linear. For example, I in I. This lone pair 1, the lone pair, second lone pair, and third lone pair. That's it. It's like that linear form. And then any another negative ion for that. In fourth one, xenon oxy pentafluoride anion. Xenon oxy pentafluoride anion. Xenon is a central atom. These are all surrounded atom. So valency of xenon Ze. In totally ns2 plus np6, 8 plus 1 negative charge plus 1, in totally 9 electrons. Those are 9 electrons. It becomes a negative charge. For example, totally 1 oxygen and 4 fluorine atoms. 1 oxygen paired with the 2 electrons and 5 fluorine atoms. 5 fluorine atoms. So these remaining electrons become to that lone pair. Totally present that 1, 2, 3, 4, 5, 6. 6 sigma plus 1 lone pair. So ZeO5 minus. Fe minus. In total value for the 7. Total value for that 7 xenon oxyfluoride pentafluoride. So 7, the hybridization for that sp3d3 with 1 lone pair. The geometry of the compound, the shape of the hybridization become to sp3d3. Geometry of the compound, pentagonal monopyramidal. For example, F, the central atom becomes xenon in the 1 lone pair electron, pentagonal monopyramidal. That's all. In last year 2019 TRB question, asked the question for that. The question for them, that video for the question. Match the following: xenon fluoride, ClF3, IF5, xenon oxide, xenon trioxide. The each option for that the 4 option for that each, for example, correct answer will be that. And then shortcut methods, for example, ZeF2 and ClF3, IF5 and xenon oxides. And easily correct options for that, the shortcut methods. For example, xenon will be similar compounds. Xenon becomes to similar compounds. Any xenon compounds, the valence electron becomes to 6. 8 electron system, 8 valence electron system. For example, 1 fluorine and 1 fluorine, xenon F2. So 2 sigma plus 3 lone pair. And most of the option for that 2 sigma is a sp3d plus 3 lone pair. The molecule becomes to linear. So xenon compound becomes to linear. And ClF3 and ClF, any 2 options will be easily detected. For example, IF5 easily known that iodine becomes valency for that 7 F. The 5 fluorine atoms will be bonded. So 5 sigma, 1 lone pair plus 1 lone pair, so 6. So the valency for that sp3d2 6. So sp3d2 plus 1 lone pair, so 1 lone pair, the structure becomes to that this one, F and F, 1 lone pair. So the structure becomes to square pyramid. Square pyramid form. And then ClF3, the chlorine becomes a central atom, valency becomes to ClF3, valency becomes to 7. In both halogen compounds, the general valency for that ns to np5, whole electrons will be added. all the electrons will be added in one fluorine, one fluorine, one fluorine. So 2 lone pair, 3 sigma plus 2 lone pair, in totally 5. For example, sp3d, the hybridization becomes to sp3d with 2 lone pair electrons. The molecular becomes to that, for example, T shape. What is the structure of the compound? What is the geometry of the compound? For example, chlorine, fluorine, fluorine, and fluorine. That's 2 lone pairs. The molecule becomes to T shape. The rest of the one becomes to that, easily understood, that trigonal family. And easily suggest level. For example, xenon oxides. Xenon oxides, the valency of the xenon 8, 2, 4, 6, 8. 1 oxygen, 2 oxygen, third oxygen is a 1 lone pair. So 3 sigma plus 1 lone pair, in totally 4 for that sp3. sp3 with 1 lone pair, in the molecular structure becomes to that trigonal pramine. Trigonal pramine. The geometry of the compound, xenon oxide compound, is xenon, that's all, trigonal pramine. So if you like that concept, becomes to like, so share the concept, share the videos with the other selves, and easily shortcut methods for that, clearly understood them. The next class started from that, maybe ESR problems or NMR problems in inorganic complexes, inorganic compounds or inorganic complexes in next another classes. Thank you.